Something we need to talk about as we head into our section on exponentials is how to tell the difference between the different types of functions or equations that we've looked at so far. So we've had three different types of equations. We've had linear equations, quadratic equations, and exponential equations. So let's talk about all three types. So if I have a linear equation, it should be in y equals mx plus b. So once it's simplified, it should be in y equals mx plus b. If I have a quadratic, once we simplify, it should be y equals ax squared plus bx plus c. And if I have an exponential, it should be in the form y equals ab to the x power. So let's talk about the differences here. So if it's a linear equation, your highest exponent, your largest degree, is equal to 1. So my x value is x to the first power. So if it's linear, we don't have any exponents other than 1. So if I look at my first equation, I have x to the first. Now you could also have something like y is equal to 3 or x is equal to 4. Now we know those make either vertical lines or horizontal lines, but they're still both linear. We don't have any exponents bigger than 1. Now my second one, I have a quadratic. So it's in the form ax squared plus bx plus c. Well, in this one, we're missing our b term. But we still have our x squared, and my highest exponent is x squared. We don't have a cubed or a fourth. And if we would eliminate the x squared, it would turn back into a linear equation. So it's got to have an x squared. And the last one, we have a initial amount, we have a multiplier, but the key here is that we have a variable exponent. Okay, so if you have a variable exponent, it's got to be exponential. So in both forms, we have that x for an exponent. It could be an n, it can be any letter, but it's got to be a variable. So again, to wrap things up, we have a linear equation, which is y equals mx plus b. We have quadratic, which we have that x squared. And we have exponential, which we have a